In this example, we are going to factor 5y to the power 5 over 3 minus 12 times y to the power 2 over 3. As you see the numbers 5 and negative 12, there is no GCF or no greatest common factor. But for the variable term, y to the 5 over 3 and y to the 2 over 3, the GCF would be the lowest power. The lowest power among these two numbers gonna be the power 2 over 3. So with this hint, we are going to rewrite the expressions in the form that we can see the factor y to the power 2 over 3 for our convenience. That means for y to the 5 over 3, we can break it up as y to the power 2 over 3 multiplied by y to the 3 over 3. Note that for the property of the exponent, a to the power m times a to the power n equals a to the m plus n. And back to the main part of the problem. The second term we can write as 12 times y to the 2 over 3, which no change. And with this way, we can see the greatest common factor from those terms. And then factor it out as y to the power 2 over 3 multiplied by the remaining factor 5 times y to the power 3 over 3 and then minus 12. Note that y to the power 3 over 3, which is y to the first power, which is the same as y. So write it in the nicer form as y to the power 2 over 3 multiplied by 5 times y minus 12. For this example, we are going to factor the quantity 3x plus 2 raised to the power negative first plus the quantity 3x plus 2 raised to the power negative fifth. We see the common quantity 3x plus 2 and 3x plus 2. Next, we're going to determine what would be the GCF of these two terms. Similar to the early examples, when we look at the variable raised to the power, the GCF would be the term that raised to the lowest power among all of the terms. In this case, we have the power negative first and the power negative fifth. Negative fifth is the lowest power or less quantity than negative 1. So therefore, the GCF for this is going to be the quantity 3x plus 2 raised to the negative fifth. Use similar technique as earlier example. We're going to rewrite it in the form of the product of the same base that has the power as one of them in the GCF form. So for the negative 1 is negative 5 plus 4. That means we can write the first term as 3x plus 2 to the power negative fifth multiplied by the quantity 3x plus 2 raised to the fourth power by using the property of the exponent as a to the m times a to the n equals a to the m plus n. It means when you have the same base, you can add the power negative 5 and 4 and now get back to the value negative 1 as the original power. Continue with the second term, which no change. It's going to be 3x plus 2 to the negative fifth. And to make it convenient, we're going to multiply by 1. At this point, you can see the greatest common factors from these two terms. We write it as the quantity 3x plus 2 to the power negative fifth and multiply by the remaining factor. From the first term, we have the remaining factor as 3x plus 2, quantity to the fourth, and then plus the remaining factor from the last term, which is 1. And now we have the factor form of this expression.